Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P2227 indicates a BARO sensor circuit range or performance problem specific to the Honda Civic models from 2011 to 2015. The BARO sensor, or barometric pressure sensor, is critical because it measures the atmospheric pressure to aid the engine control unit, ECU, in determining proper air-fuel mixture for optimal combustion. This sensor plays an essential role in the vehicle's performance and fuel efficiency. When this DTC is present, it signifies that the readings from the BARO sensor are outside their specified range, potentially leading to poor engine performance or increased emissions. It is crucial to address this issue, not only to restore the vehicle's efficiency, but also to adhere to emissions regulations. Prior to beginning any troubleshooting, ensure to document any freeze data, which captures the conditions at the time the code was triggered, as well as an onboard snapshot, which provides a key insight into the system at that moment. Moreover, review any other DTCs that may be present, especially related codes like P0107, P0108, P1128, and P1129, since they should be prioritized in troubleshooting. The BARO sensor is designed to measure atmospheric pressure, providing data to the engine control module, ECM, for proper engine calibration. This sensor is typically located in the intake manifold or near the air cleaner, positioned for accurate exposure to atmospheric conditions. It works by producing a voltage signal corresponding to the atmospheric pressure, which is used in various calculations by the ECM to ensure efficient engine operation. If the atmospheric pressure deviates from the expected levels determined at sea level, approximately 101 kilopascal or 29.9 inches per minute, the engine may experience performance issues. These problems can include erratic engine idling, decreased fuel economy, or even stalling. Understanding the role of the BARO sensor is vital, as it directly impacts air-fuel mixture calculations, thus affecting overall engine performance and emissions levels. When addressing DTC P2227, several possible causes need to be considered. Firstly, a faulty BARO sensor is often the primary suspect. Sensors can fail due to wear, corrosion, or electrical failures. Secondly, the engine control module, ECM, may have outdated software that does not function correctly with current vehicle data, causing inaccuracies in sensor readings. Furthermore, wiring issues, such as shorts, opens, or corrosion in the wire harness connected to the BARO sensor can distort the signals sent to the ECM, triggering this DTC. Each of these conditions must be thoroughly evaluated to identify the root cause of the problem. Establishing the correct operation of the BARO sensor and the integrity of the associated wiring is essential to ensure accurate atmospheric measurements and optimal engine performance. The symptoms associated with DTC P2227 can manifest in several noticeable ways. Drivers may experience erratic engine performance, characterized by unstable idling or unexpected stalls, which could create safety issues during operation. Additionally, a significant drop in fuel economy can occur as the ECM struggles to calibrate the air-fuel mixture properly with faulty BARO sensor readings. This inefficiency translates into higher operational costs as the vehicle consumes more fuel. Increased emissions might also arise from improper fuel combustion due to erroneous atmospheric pressure readings, possibly leading to failed emissions tests or environmental concerns. Recognizing these symptoms can guide technicians in promptly addressing the underlying issues associated with the BARO sensor circuit problem. The first step in troubleshooting DTC P2227 involves checking the performance of the BARO sensor. Begin by turning the ignition switch to the on-to position and allowing the vehicle's systems to initialize for about 2 seconds. Following that, utilize the Honda Diagnostic System, HDS, to check the BARO sensor data. At sea level, the BARO sensor should indicate approximately 101 kilopascals, which is equivalent to 29.9-inch stage, or 760 millimeters Hg, or about 2.9 volts. If the readings fall within this expected range, you will proceed to the next step in the troubleshooting process. However, if the readings deviate from these values, the next actions would involve either updating the ECM with the latest software or substituting a known good ECM. This ensures that any software-related issues are resolved, as they may lead to inaccurate sensor readings. The next step in the troubleshooting procedure begins with clearing the fault code using the Honda Diagnostic System HDS. Next, start the engine and hold the engine speed at 3,000 RPM without load until the radiator fan activates, thereafter allowing the engine to idle. In this step, you want to ensure that certain operational conditions are met for an effective test drive. Specifically, the engine coolant temperature ECT sensor 1 should be above 158 degrees Fahrenheit, 70 degrees Celsius, and the transmission should be in 4th gear. Furthermore, the throttle position sensor, REL TP sensor, should register between 16 and 28 degrees for a minimum of 3 seconds. It's important to monitor the OBD status during this test. If it indicates failed, then the issue is replicated. However, if the HDS shows a status of passed, the system is currently functioning correctly. And if it shows not completed, the second part of the process should be revisited. In this step, the focus shifts to the intake air system, which is critical for the engine's air intake performance. Begin by inspecting the entire intake air system for any signs of clogging or restrictions caused by foreign materials and dirt accumulation, especially in the air cleaner element. A clogged air intake can severely affect engine performance as it hinders the proper flow of air. If you find any blockages, it is essential to remove these obstructions promptly. Should the intake system remain clear, yet the DTC persists, the next course of action involves updating the ECM with the latest software, or alternatively, substituting with a known good ECM. This addresses the possibility of software-related inaccuracies that could be distorting the BARO sensor readings. Completing this inspection meticulously can help restore appropriate air intake levels and solve the performance problem indicated by the DTC. After addressing the issues identified in the previous steps, it's crucial to verify that the repair has been successful. Start by turning the ignition switch to the on-to position once more. Use the Honda Diagnostic System, HDS, to reset the engine control module, ECM. Following this reset, you must perform the ECM idle learn procedure, a critical step that helps the module recalibrate itself after changes have been made. The next process involves starting the engine and holding it at 3,000 RPM without load until the radiator fan turns on, then allowing the engine to return to idle. Subsequently, test drive the vehicle again under specific conditions to validate successful operation. Ensure the engine coolant temperature exceeds 158 degrees Fahrenheit, 70 degrees Celsius. The transmission is in 4th gear, and the throttle position sensor readings are maintained for 3 seconds. Monitor the OBD status for DTC P2227 once more to confirm whether it shows passed, signaling the resolution of the earlier issues. After the final verification step, it is essential to conduct a thorough review of the onboard diagnostic (OBD) status. This will provide an indication of whether the troubleshooting efforts have resolved the issue at hand. The HDS will detail whether the DTC P2227 now shows as passed, which indicates that the sensor is functioning within expected parameters after repairs. Should the status indicate failed, this signifies that the issue persists, requiring you to revisit earlier troubleshooting steps and possibly replace the ECM if updates were already applied without success. If not completed appears, it suggests that conditions haven't been met for proper evaluation, and further testing is necessary. Every completed step contributes towards ensuring the vehicle's ECM is functioning correctly, ultimately safeguarding vehicle performance. To avoid recurrence of issues related to DTC P2227, proactive preventive maintenance plays a pivotal role. Regular inspections of the BARO sensor should be scheduled, ensuring its functionality remains optimal. This can help detect issues before they lead to performance problems. Keeping the ECM software up to date is equally important, as manufacturers periodically release updates that can enhance functionality and address previously identified issues. Additionally, routine maintenance of the air intake system cannot be overlooked. Ensure that the air cleaner element is clean and free of debris. Consistent upkeep of these components will promote efficient engine operation, lower emissions, and maintain fuel efficiency. By instigating preventive measures, vehicle owners can prolong the sensor's lifespan and minimize the likelihood of future DTC P2227 occurrences. In conclusion, the BARO sensor's functionality is critical to ensuring the optimal performance of Honda Civic models from 2011 to 2015. The troubleshooting process for DTC P2227 involves systematic checking and verifying conditions, addressing potential causes, and implementing corrective actions. By diligently following these steps, technicians can accurately diagnose and repair the underlying issues. Furthermore, emphasizing regular maintenance will help in averting future occurrences of this DTC, fostering a better performing engine and compliance with emission standards. Effective monitoring of the BARO sensor and the ECM will not only enhance driving experience, but also ensure adherence to environmental regulations. Understanding and addressing BARO sensor issues can significantly enhance vehicle longevity and performance. Please like and subscribe to the channel. See you next time.